Hello students, how are you? All good? All are doing well at their homes? That's very good. Nice. अच्छे से पढ़ाई कर रहे हो? Are you studying well at home? Yeah, have you seen the previous videos in physics? You know who am I? I am Mahesh. I teach you physics on my YouTube channel, SMR Online Physics. If you haven't watched any videos which was about plane mirrors and reflection of light by plane mirrors and small important mathematical derivations, do watch both the videos, and this is the third part of the series. Today we'll talk about some kind of specialized curved mirrors. Alright? Those are called spherical mirrors, also called as curved mirrors. So the topic of the day is spherical mirrors. I think most of you have studied in your lower classes about spherical mirrors. सुना तो हो गई? I think you definitely have heard about this kind of mirrors, which are not very commonly used in our homes. I mean to say, whenever you're trying to get ready for a party, for a school, for a function, most of us stand in front of plane mirrors, not in front of spherical mirrors. But spherical mirrors also have tremendously good uses in our day-to-day life. Let us learn about spherical mirrors in the most easiest and the most interesting way possible. Alright? Spherical mirrors. Why the name spherical mirrors? Definitely, it's very easy to guess. You're intelligent and smart enough. The word actually comes from the term called sphere. It comes from the term called sphere. So, is it like a spherical ball which I'm talking as a mirror? No, definitely not. It can be put up in a museum or in the science galleries for a spectacle, but definitely not for a regular usage. A spherical ball which will be acting as a mirror. Alright? Okay. I mean to say, these mirrors form or imagined to be a part of a large hollow sphere. Hence, the name is spherical mirrors. Let me just quickly get into those two very well-known types of spherical mirrors. They are subdivided into two names. One we know as the concave spherical mirror. The other one we call as convex spherical mirror. So I can call it as concave mirror, and this one is as convex spherical mirror. Is that all right? Okay. So most of the students I found in my teaching career in the last 15 years, that they tend to slightly get confused, particularly in exams, which is very common tendency of any student to get confused up if you haven't practiced properly or if you haven't understood the differences and the concept hidden in these mirrors. Concave, convex. These are like English words which we have taken up to make our understanding much simpler and better. Concave. Concave refers to any surface which is curved inwards. Any surface which is curved inwards. Then we attach the word mirror, so it becomes a concave mirror. Otherwise, I'll just show you any surface which is curved inwards can be called as concave. On the other hand, convex. The word convex means something which is bulging outward. A surface which is bulging outward is preferably called as a convex surface. Since I'm talking about a mirror, so we call it as convex mirror. Alright? Let me just show it to you. A very simple tool in our kitchens can be easily kept in our heads as a very specialized tool to make ourselves understand better what is a concave or convex mirror. Now, if you watch this surface of the mirror, hope I'm clear. Yeah, if I'm showing you the side view, you will see that the surface of the spoon, one side is curved inwards. This surface will be called as the concave surface of the spoon On the other side, which is also equally very smooth and polished, it is bulging outwards, so the name will be convex surface of the spoon. Hence, it's very easy to remember also. Concave, inwards, convex, bulging outwards. Now, why they are called spherical mirrors? Let me just show it to you. I have this spherical ball, which I just made it for you to make your understanding easier. Imagine this is a sphere, which is like very shiny sphere, all right? And you can see that this is a hollow sphere inside, of which these mirrors form or imagine to be a part of it. For example, if I have to just remove this part, what I get is this. I get this. You see this? You see this? This surface is bulging outwards. It could have been imagined to be a part of a large hollow sphere, which I just showed it to you. So this sphere which is curved outwards is called the convex surface, and the surface which is curved inwards is called as concave surface. Convex and concave. I think till here I'm very pretty clear to you how to make a differentiation between concave and convex mirrors. Am I clear till here, students? Yeah. If I'm clear and right now you're enjoying this video, trying to understand, you find that concave and convex mirrors have never been so simple to understand, then give a like to the video and don't forget to subscribe my YouTube channel. Thank you. Now I'd like to quickly show up this same spoon. Let us imagine this pencil to be the object. If I place this pencil closer to the concave surface of the spoon, just see the image what you get in the spoon. The concave surface, I hope I'm clear, it will be inverted, upside down. Whatever you get to see in the spoon right now, the concave surface, everything is upside down. But on the other hand, the things may be very different. Very different. You can see that the surface is, you can see plenty of things. You can even see the ceiling fan over there, and you can see the spoon surface, the pencil, and you'll find it is erect but smaller in size. A lot of things can be seen in the spoon if you observe it closely. So there is a difference in the concave surface forming images and convex surfaces forming images. If I really get closer, you will find that the image really becomes upright, but at the same time it becomes magnified also. So my dear students, I hope I'm clear with the simple device or tool which is available in everyone's kitchen to identify which one is concave and convex surface. Okay, now let me just discuss in brief details with much clarity for sure how to really draw it on paper. Once we have visualized what are spherical mirrors, how to draw a concave mirror. Let me write it down here. The concave mirror. I'm sure after this class, after you see through this video, definitely none of you will have any issues in remembering the properties and everything about concave and convex mirrors. All right? Okay, let me just first of all show you how to get it right. This is concave mirror, a spherical mirror whose reflecting surface is curved inwards. Remember the inner curve of the spoon. The inner curve of the spoon is called as the concave surface. So when we draw it on paper, I just show you the reflecting surface with this yellow colored mark, and this is the non-reflecting or the polished surface which we even have seen in case of plane mirrors. Yeah. Now to draw convex mirror, we just draw this arc and make it sure that the non-polished surface is now inside and the reflecting surface, that is the mirror part, is actually curved outwards. The mirror part is actually curved outwards. That is called as your convex mirror. I think, my dear students, you remember it is the outer bulge of a stainless steel spoon, which we call as the convex surface, and this is the inner curve, which is better called as a concave surface. Here it is. This is the visual representation of concave mirror and the convex mirror. So they can be imagined to be part of a large hollow sphere, as I already showed you with a visual demo about it. In this case also you can see that it can be imagined to be part of a large hollow sphere. So this imaginary sphere will have a center of its own. This is called by the term C. C in this case is to the left side. In this case you can see the center of curvature of the hollow sphere is lying to the right hand side. So let me write it down here. C stands for center of curvature. Right? Okay, good. There's another very important point about these mirrors is there is a midpoint. There is a midpoint lying on the reflecting surface. The midpoint lying on the reflecting surface is denoted by capital P. In the same case for convex mirrors, the midpoint lying on the reflecting surface is denoted by P, and that P stands for pole of the mirror. That is called as the pole of the mirror. Right? A straight line or imaginary line passing right through the center of curvature and pole of the mirror is called as your principal axis. In the same way we can show it for convex mirror. A line joining the pole and the center of curvature is called as the principal axis. So definitely it can be drawn as a bold line, not a big issue about it, right? So let me draw it for you. This is your principal axis of a concave mirror. This is your principal axis for convex mirror, and that has to be dotted line behind the mirror because the rays of light cannot pierce through an opaque surface. Definitely yes. It is an opaque surface, but it's a very shiny, smooth surface, very excellent reflector of light. So we got these terms called pole, the center of curvature. A line joining the center of curvature and pole is called as the principal axis. Is that clear? Give me a thumbs up. Right. Now let me talk about a very, very important term about the mirror. Focus on your studies. This is a very, very common terminology, very common saying from all the sides. Your teacher, your parents, your elder brothers and sisters, everyone keeps on saying to you, focus on your studies. What does the focus exactly mean here? Focus actually means to concentrate your total bodily and physical energy and mental energy onto your target. That is, to study, understand, remember, and perform well in your exams and perform well in your life. Understood? So the meaning of focus is very, very crystal clear in our real life also. That kind of a terminology also appears in the spherical mirror terms. How it looks like. Now, if you allow the sunlight to be incident upon the reflecting surface of a concave mirror, then the reflecting surface of the concave mirror being curved inwards makes the reflected rays to reflect in such a way that the entire beam of light happens to converge by itself at one common point, which is generally found to be on the principal axis. This meeting or converging point is denoted by capital F. Let me write it down here. Capital F standing for principal focus. It is called as the principal focus, and you should be very, very clear, which is very evident from this explanation, that mirrors will have only one focus, and that is the point. Where the entire light rays, after getting reflected from the reflecting surface, converge at one point, meet at one point, that specialized point is called as the focus. Try to understand, boy or the girl, whoever is listening to my lectures right now, make it sure that this point is only somewhere in the air, not on the surface of the mirror. So if this is your concave surface, so the focus will lie somewhere here, and similarly center of curvature lies somewhere in the air. The point which lies on the reflecting surface, which is the midpoint of it, that is actually called as the pole of the mirror. Hope I'm absolutely clear. Now many of the students might have immediately jumped up to a new terminology by themselves also. Sir, I can see that the concave mirror by itself is making the light rays to reflect in such a way that the entire reflected beam happens to meet at one point, and we have heard this term. This behavior of the mirror which makes the reflected rays of light to meet at a point is called as the converging behavior of concave mirrors. Hence, concave mirrors are also popularly called as converging mirrors. They are also called as converging mirrors, as it is very clearly evident from this diagram. This is what exactly will happen if you hold upon a concave mirror in your hands and just allow the sunlight coming from very, very far away distance onto the mirror. Now let us see, if I allow the same sunlight to be incident upon the reflecting surface of a convex mirror, what will the convex mirror exactly do? In this case, you'll find the reflecting surface is actually curved outwards, so hence we find that here onwards the light bounces off in such a way, here onwards the light actually bounces off in such a way that if I produce this reflected beam of light, or the reflected rays of light backwards geometrically, then I find that all these reflected rays of light happen to meet at one common point, which is actually a virtual intersection, which we know and which we have seen in case of plane mirrors behavior. And this virtual intersection of the reflected beam is also denoted as F, F standing for the same terminology called principal focus. It is called as the principal focus. My dear students, please observe the difference. Here, if you observe it very closely, then you should find that this entire reflected beam seems to emerge from one common point on the principal axis, as if the journey has started something this way, going away to different directions. Such behavior is also called as diverging behavior. Hence, convex mirrors, no surprise, are also called by the name diverging mirrors because of this behavior. So hence, in case of a convex mirror, we can't find a focus which can be obtained on an opaque screen. Whereas in case of concave mirrors, we can definitely find this focus point on an opaque screen. Hence, this focus for a concave mirror, my dear students, remember, is also a real image, or we can call it a real focus, whereas on the other hand, the focus obtained for convex mirror is non-real, which we generally tend to call as virtual image or the virtual focus of the convex mirrors. Hope I'm very clear till here. So let me just remove one particularly good question which I did not discuss yet. What if the ray of light happens to come along the principal axis of both the mirrors? Where would that reflected ray go, sir? You may be thinking about this question. The answer, most of it, just put a thought for it. Those who have attended the previous videos on the plane mirrors, you should be getting the right answer. Did you get it? Yes. In this case, this ray of light is making an angle of 90 degrees with the surface, in both the cases in fact, and such a case is called normal incidence. It's almost like you take a tennis ball, hit it straight on the floor, and you find the tennis ball bounces straight back up. So this is a case of normal incidence, and hence you find the reflected ray retraces its path along the principal axis. So that's it. In all the cases you can see we have done everything perfectly. Converging behavior of concave mirrors, convex mirrors are always performing diverging behavior with respect to the light. I ask you, all of you, those who are attending very sincerely, please note it down in your copies. Right? Now let me discuss some more important terminologies which we should know and are going to be very helpful in our future class regarding the spherical mirrors. I think everyone have noted down these diagrams correctly, and now we'll talk about certain more terms. One of the very important terms is the size of the reflecting surface itself. If you observe the size of this reflecting surface, definitely it is not a surface which can be directly measured with a straight ruler or a scale. Okay? So since the surfaces in general do not have larger curvatures, we can also say as the net diameter of the reflecting surface of the reflecting mirror, that is concave or convex mirrors, by a new terminology that is called, let me represent it in the diagram, mm dash. Mm dash. This mm dash in the diagram, which represents the size of the mirror, is better known as the aperture of the mirror. Is that clear? That is called as the aperture of the mirror. Okay, good. That basically indicates how large is the reflecting surface of your mirror. Larger is the reflecting surface and quality is supremely good, better quality of images will be obtained by the mirror. Okay? Now, talk about two important distances. One, the distance measured from the pole of the mirror to the focus. This is a distance which is measurable experimentally, and this distance is denoted by smaller f. Come on, get me the name. F standing for focal length of the mirror. Absolutely correct. This distance between the pole and the focus in both the mirrors is called by the term focal length of the mirror. And one more important distance is from pole to the center of curvature of the mirror. From pole to the center of curvature, this distance, can you guess this distance name? Yeah, it comes from the studies of circles, because it is the distance from the center of a circle or the center of a sphere to its circumference, and hence the correct name. This distance between pole to the center of curvature is denoted by capital R standing for radius of curvature. It is called as the radius of curvature of the mirror. Same here. From pole to the center of curvature for convex mirror is called as a radius of curvature. Hope I'm very clear till this point. Please do revise this topic until we meet once again and move forward with our wonderful explanation and discussion on spherical mirrors, how they form images, what is a real image, what is a virtual image, and everything else. If you have liked this video and you found that it's really helpful for your enhancement of knowledge on spherical mirrors, do not forget to like it and share it among your friends, and just don't forget to subscribe the button, okay, of my YouTube channel SMR Online Physics. Thank you. Have a good day. Enjoy, study, stay safe, stay fit. Thank you very much. Bye.